Welcome back to IM1. Today's topic 3.3.2. How can I rewrite it or undo it? The learning target for today says I will be able to find more ways to rewrite equations, and I will learn what it means for the equations to be equivalent. So, problem 3120, more solving by rewriting. It says Sean was trying to solve for x in the equation zero point 0.4 times x minus 2 equals 3.4 minus 0.2x. He said to his teammate April, decimals, I wish that we only had equations with whole numbers. So suddenly April blurted out, wait, Sean, I think there's another way. Can you first rewrite the equation so it has no decimals? And then it will be faster and easier to solve. So what is April talking about? And explain what she means, then rewrite the equation so that she has no decimals. So one of the things you guys can do here, if you notice, is that everything is in the tens place, right? Right there on your decimal. So if I multiply everything by 10, it's going to move it one decimal. It's going to move the decimal one to the right. So that's one of the things we can do. So we can multiply everything by 10. All right. And if we do that, so we put 10 times 0.4 times x minus 2 equals 10 times 3.4 minus 0.2 times x. All right. So if we do distribute, so remember, make sure you guys multiply both sides of the equation, not just one side. So if we do distribute, so it would be 10 times 0.4. In this case, you only have to give it to this part, and that's it. So here it's going to be just 4 times x minus 2 equals 10 times 3.4. That would give you guys 34. And then 10 times 0.2x, that would be minus 2x. So again, in this case, we've rewritten the entire equations without having any decimals. So now question part B says, now solve the new equation, the one without decimals, and then you want to check your solution. So here we're going to distribute 4 times x minus 2. So that's going to give us 4x minus 8 equals 34 minus 2x. And again, as always, you want to make sure that you put all your x's on the same side. So here I'm going to add 2x to both sides. And that gives us 6x minus 8 equals positive 34. You add 8 to both sides, you get 6x equals 34 plus 8 gives you 42. Divide both sides by 6 and you get x equals 7. So here what we want to do is we want to check our answer. Always want to plug it back into the original equation. It's very important that we always plug it into back to the original. So the original was 0.4 times x minus 2 and then equals 3.4 minus 0.2x, right? So here, again, what you want to do, substitute minus 2, and we're checking to see if that's equal to 3.4. 3.4 minus 0.2 times 7. All right, so that gives us 0.4 times 5, and that would be just 2. And then we want to see if that's equal to 2 as well. So 3.4, 0.2 times 7, that's 1.4. So 3.4 minus 1.4 is also 2. So our answer checks off, even though we did get to it in a different way. All right, so let's look at question 3121. Rewriting 0.4 times x minus 2 equals 3.4 minus 0.2x. And problem 3120 gave you at least one new equivalent equation that was much easier to solve. It says two equations are equivalent if all the solutions are the same. There are several ways to change one equation into a different equivalent equation. Common ways include adding or subtracting the same number from both sides, or multiplying or dividing both sides by the same non zero number. Rewrite an equivalent equation for each equation below, and be sure your equivalent equation has no fractions or decimals, and then solve the new equation and check your answer in the original equation. So again, we're going to do the same thing. If you notice on part A right here, we have pretty much negative 7.5x squared plus 4.8x minus 0.3 equals 2.5x squared plus 10.02 minus 10x squared. So one of the things we can do here is, again, we want to get rid of the decimal, right? So here we want to multiply everything by In this case, we have in the 100s place, we have a 0.2. So let's multiply everything by 100. So that's going to give us 100 negative 7.5 times x squared plus 4.8 times x minus 0.3 equals 2.5 x squared, and then plus 10.02 minus 10 x squared times 100. All right. So again, since this is in the 100s place and we want to multiply everything by 100. So here we're going to have 100 minus 7.5. So that's going to be negative 75x squared. All right. And then the next one's going to be 48 plus 48x minus 30x. So distribute the 100, you're going to get 100 times negative 7.5. Move the decimal 2 to the right. So that's going to be negative 750 x squared. 2 to the right. So it's going to be plus 480 x minus, move 2 to the right again. So it's going to be minus 30x, just 30 by itself, equals, again, 2.5 times 100. That's going to be 250 x squared plus, get rid of the decimal here. So it's going to be plus 1002. And then 10 times 100 gives you 1000. So minus 1000 x squared. All right, now we want to solve the equation. In this case, we're going to have negative 750, right? So I'm going to add 750 or add 1000 x squared to both sides. So that gives us 250 x squared. And then here, plus 480x minus 30 equals 250x squared plus 1002. So here, subtract 250x squared from both sides. That goes away with that. And then you have 480x minus 30 equals 1002. So add 30 to both sides. We're going to end up with 480x equals 1032. Divide both sides by 480. And that gives us a total of x equals 2.15. And again, you want to check it, make sure that your answer is correct by substituting back into the original equation, right, which is this one. Make sure you guys do the check. I'm just not going to do it just to save some time. All right. And then, so in part B, we have 2,000 times x minus 24 plus 5,000 equals 8,000. So one thing you guys can do here before you distribute this, so it's pretty much you can subtract 5,000. So we're going to rewrite this. And then you're left with 2,000 x minus 24 equals 13,000. And then divide everything by 2,000. All right, so it gives you x minus 24 equals 11,000. Add 24 to both sides. And you end up with x equals 11,024. So look again at part B of problem 121. And it says you also use undoing to solve. Explain how you use undoing to solve. So in this case, you're undoing it to solve, right? Because we undid everything that was happening around the x. So we undid